Hi everyone, today we're going to be talking about geometric series. So in my previous video I noted that a geometric sequence, here's an example, it's 3, 6, 12, 24, 48, so each time we're multiplying by 2. So a geometric sequence is a sequence where each term is multiplied by a certain common ratio to get to the next term. And a geometric series is similar, but instead we're just adding each number in the sequence. So what if we want to find the sum of the first n terms of a geometric series? So for example, let's say we want to find the sum 3 plus 6 plus 12 plus 24 plus 48. And this goes on, but let's just say we want to find the first 5 terms of this sequence. Then what are we going to do? Well, we have a formula right here that tells us the sum. So it says S sub n equals a sub 1 times 1 minus r to the power of n over 1 minus r. So S sub n stands for the sum of the first n terms. So this is the sum of the first n terms. A1 is the initial term, so in this case it would just be 3. R is a common ratio, and that is what we multiply each number by to get the next term. So we have 3 times 2 equals 6, times 2 equals 12, times 2 equals 24, so this would just be 2. And n is the number of terms, or the nth term. So in this case, if we want to find the first 5 terms, we would use n equals 5. So how did we get this formula? So I'm just going to derive the formula right here. So in my previous video, I said that to find the nth term of a geometric sequence, the formula is a sub n equals a sub 1 times r to the power of n minus 1. So if we were to write each number in the sequence out, or each term out, we have a1 times r, and then this is the first term, so it's going to be r to the power of 1 minus 1, which is just 0. The next term is going to be a1 times r to the power of 1, because it's the second term, so it's going to be 2 minus 1, so it's going to be 1. Then the third term is going to be r to the power of 2, then the fourth term is going to be a sub 1 times r to the power of 3, and it's going to go on and on until the last term of the sequence, which is a1 times rn minus 1, because it's just going to be, this is the nth term. So it's the first, second, third, fourth, and blah, 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 all the way to the nth term. And so if we want to find the sum, which is noted as s sub n, we're just going to add all this up. So we have a1, and r to the power of 0 is just going to be 1, so I'm just going to leave that as a1, plus a1 times r, plus a sub 1 times r squared, plus a sub 1 times r cubed, plus, and all these numbers, all the way up to a sub 1 times rn minus 1. So if we add all these numbers up, we're going to get the sum of the sequence, which is what we want to find. But now I'm going to multiply this whole equation by r. And the reason why I'm doing this is because I want to try to get rid of this n minus 1 because it makes things confusing. And if we multiply r to this, so if we do rn to the power of 1 times r, remember that we can just add the exponents. So this is just going to be to the power of 1. So it's going to be r to the power of n minus 1 plus 1, which is just equal to r to the power of n. And this would make it a lot easier to work with, so I'm going to multiply with r. So here I'm going to multiply r, so I have a1 times r plus a1 times r squared plus a1 times r cubed plus a1 times r to the power of 4 plus, and this is going to be all the way to plus a1 times r to the power of n. And then what I'm going to do is I'm going to subtract Sn minus r times Sn. So Sn minus r times Sn. Oh, sorry. And the reason why I'm doing this is because I can cancel a lot of this really long kind of addition up. And the reason why I want to cancel it up is I want to make a simple formula to find Sn. So, sorry. So here we have, when I take this minus this, I can cancel this out because a1 times r minus a1 times r is just going to be 0. And a sub 1 times r squared can cancel out with a sub 1 times r squared, and this can cancel out, and obviously the next term right here is going to be a sub 1 times r4, so this is going to cancel out with the next term right here, which I didn't write out. I just wrote it as dot dot dot. And a sub 1 times r to the power of n minus 1 is going to cancel out with the a sub 1 times r minus 1 here, but I just did not write it out. But the term before this, before a sub 1 times rn, is going to be a sub 1 times rn minus 1, because it goes like 4, 3, 2, 1, so this is going to be n minus 1. So this is going to have something to cancel out with. So the only terms we are left with is a sub 1 and a sub 1 times r to the power of n. So if we subtract that, we have a1 minus, a sub 1 minus a sub 1 times r to the power of n. And then I'm just going to solve this for Sn. So I'm going to do Sn 1 minus r equals, and I'm going to take out the a sub 1, so I have 1 minus r to the power of n. And then to solve for S sub n, we have S sub n equals a sub 1 times 1 minus rn over 1 minus r. So this is the formula we get for the sum of the first n terms of a geometric sequence. And that's the same thing as what I just wrote right there. So this is how the formula is derived. You don't really need to know the derivation, but it's interesting. Okay, so we're going to try to use that formula to solve these next few problems. So the first problem says, find the sum of the first 10 terms of the sequence, 1,536, 768, 384, 192, and so on. So I'm going to write the formula here. So we have S sub n equals a sub 1 times 1 minus r to the power of n over 1 minus r. So we're just going to find a sub 1, r, and n and substitute it into this formula. So a1, or a sub 1, the first term of the sequence, is going to be 1,536. And r, the common ratio, we're dividing by 2 each time here, which is the same thing as multiplying by 1/2. So the common ratio is 1/2. And n, we want to find the first 10 terms, so I'm going to make that 10. So the sum of the first 10 terms is going to be 1,536 times 1 minus 1/2 to the power of 10 over 1 minus 1/2. And if we simplify this, we have 1,536 times 1 minus 1 over 2 to the power of 10 is 1,024 over 1 minus 1/2 is just going to be 1/2. And if we're dividing by 1/2, it's the same thing as multiplying by 2, because if we're dividing by 1/2, it's the same thing as multiplying by 2, right? So I'm just going to multiply this whole thing by 2 instead and get rid of the fraction on the bottom. So it's going to be 2 times 1,536 times 1 minus 1 over 1,024. And then I'm going to use my calculator here. So the 2 is covered, but there was a 2 there. So 2 times 1,536 times 1 minus 1 divided by 1,024 equals 3,069. So our answer is 3,069. So the sum of the first 10 terms of this sequence is 3,069. Okay, next problem says, what is the first term of a geometric sequence where S sub 8 equals 3,280 over 81 and S sub 4 equals 40 over 81? So here we have two, it's sort of like when you want to find the equation of a line and you have 2 points. So we have 2 points, like points, and we want to try to find the formula. So we're going to use the formula here, Sn equals a1 times 1 minus r to the power of n over 1 minus r. And what we're going to do is we're going to plug this into this formula right here, and plug S sub 4 into the formula right here, and then solve for the two variables. The two leftover variables, which is going to be a sub 1 and r. And what we want to find is a sub 1, but we sometimes need to find r to find a sub 1. So here I'm going to write this down. So S sub 8, which is the sum of the first 8 terms of the sequence, is a sub 1 times 1 minus r to the power of 8 over 1 minus r. And this equals 3,280 over 81. And another equation we can make is using this information we have here. So S sub 4 equals a1 times 1 minus r to the power of 4 over 1 minus r equals 40 over 81. So we have two equations right here, sort of like how we would make, let's say we have two equations of a line and we want to find the intersection point. This is sort of the same concept. So we have two equations, and we want to find r and a sub 1. And we can find those two missing variables by using these two equations. So since r might be a little bit complicated to solve here, I'm going to solve for a1 on both sides, and I'm going to make them equal to each other. And there are multiple ways to do this, but I think I'm just going to do that way. So I'm going to solve for a sub 1, and then I'm going to make those two a sub 1s equal to each other, and then I'm going to solve for r. So here, to solve for a sub 1, I'm going to multiply by, here I'm going to write in red, I'm going to multiply this whole thing by 1 minus r over 1 minus r to the power of 8. So then I have a sub 1 equals, and this is going to cancel out with this, so I just have 3,280 over 81 times 1 minus r over 1 minus r to the power of 8. And I'm going to do the same thing here, but this time I'm going to multiply this with 1 minus r over 1 minus r to the power of 4, so this can cancel out. So we have a sub 1 equals 40 over 81 times 1 minus r over 1 minus r to the power of 4. So basically I just multiplied this equation right here by this, and this canceled out. So we have a sub 1 on this side, but on this side it doesn't cancel out, so I'm just multiplying it out. So I have a sub 1 equals this, and a sub 1 equals this, and since a sub 1 is going to be the same for this geometric sequence, because it's the same geometric sequence, so I can make this equal to each other. So we have 3,280 over 81 times 1 minus r over 1 minus r to the power of 8 equals, and this a sub 1, which is 40 over 81 times 1 minus r over 1 minus r to the power of 4. And then I'm just going to solve for this. So I'm going to, I'm just going to write this out. I'm going to take away this multiplying sign by going 3,280, 1 minus r over 81 times 1 minus r to the power of 8. This is basically the exact same thing. So 1 minus r times, or over 81 times 1 minus r. Okay, so I'm running out of space, so I'm just going to put this on the next document. Hold on. Okay, so then to solve this, I'm going to cross multiply. So we have 3,280 times 81 times 1 minus r times 1 minus r to the power of 4, so I just did this first, equals, and then to do this, I'm going to do 81 times 1 minus r to the power of 8 times 40 times 1 minus r. And then I'm going to start canceling this out. So I can divide by 1 minus r on both sides. But when we divide by 1 minus r, this is going to be something over 1 minus r, so like this number here over 1 minus r. But we have to remember that r can't equal 1 if I'm going to divide by 1 minus r on both sides, because then it will be something over 0, and you can't divide a number by 0, so I have to remember this. R cannot equal 1. R cannot equal 1, and that's just a rule I have to remember when I solve it in the end. Okay, and I can also divide by 81 on both sides. So then we're left with, we can also divide by 40 on both sides, and 3,280 divided by 40 equals 82. So we have 82 times 1 minus r to the power of 4 equals 1 minus r to the power of 8. So I'm going to solve for r here. So I have 82 minus 82 times r to the power of 4 equals 1 minus r to the power of 8. And I'm going to put everything on one side, so I'm going to subtract 1 minus r to the power of 8. So I have r to the power of 8 minus, here I'm going to write in different order. So I have this first, and this goes here. And then I'm going to do this. So I have 82 times r to the power of 4, and then I'm going to subtract 1. So I have plus 81 equals 0. And to solve for this, what I'm going to do is I'm going to make r to the power of 4 equal to x, which means r to the power of 8 is equal to x squared. So if I substitute x, it's going to make this a lot easier to solve. So I have r to the power of 8, which is x to the power of 2, minus 82 times r to the power of 4 is x, plus 81. So this is really easy to solve. It's just factoring. So we have x minus 81 times x minus 1 equals 0, and we're left with x equals 81 and x equals 1. But this, remember, we're not trying to solve for x, we're trying to solve for r, so I have to substitute r back in here. So I have r to the power of 4 equals 81 and 1. When I solve for this, I get r equals 3 and 1. But remember from before that r can't equal 1. So I'm going to cancel that out, and in the end I get r equals 3. So since I'm running out of time here, I'm going to continue this in the next video.